Welcome to clickmyproject.com. Now we discuss about the product for a low latency and low power hybrid scheme for on-chip networks. Next we see the abstract for the product. With the rapid development of advanced nanometer IC technology, continuously shrinking transistor dimensions allow designers to integrate and increasing the number of processors and IP cores into a single chip. Traditional bus-based communication is no longer suitable due to its poor scalability. Instead, network on chip has emerged as a scale of unpromising solution to global communication within the large multi-core system. Typical example on the 48-core SEC processor and the 64-core till 64 chip microprocessor and the 80-core processor. All these examples explore the packet switched NOCs which bridge a advantage of highly flexible and highly bandwidth communication. However, such merit is achieved by exploiting a complex route pipeline. This pipeline stage as a baseline PS router include the buffer write stage, the route computation stage, the visual channel allocation stage, the switch allocation stage, and the switch transfer stage. On the one hand, the complex router pipeline leads to a high latency ratio. Although looking routing and aggressive specialization shorten the critical path through the routing stage, the PS router still occupies the high ratio of communication latency when compared to the one cycle link delay is a mesh connected NOC. On the other hand, the complex router pipeline leads to a high power ratio. Network on chip has emerged as a visual factor that determines the performance and power consumption of many core systems. This paper proposes a hybrid scheme for NOC which aims to obtain low latency and low power consumption. In this presented hybrid scheme, a novel switching mechanism called visual circuit switching is proposed to intermediate with the circuit switching and packet switching. Filter traveling in the visual circuit switching can traverse the router with only one stage. In addition, multiple visual circuit switched connections are allowed to share the common physical channel. Moreover, the path allocation algorithm is proposed in the paper to determine the VCS connection and the circuit switched connection on the mesh connected NOC such as the both communication latency and power to be optimized. So we optimize the topology and to modify the mesh topology to star based topology and to improve the latency and power consumption level for overall focus for NOC architecture designs. Next we see the flow diagram for the product. First, the input data bits are applied to our NOC architecture. The network on chip, we design the 4x4 based NOC architecture design. These 4x4 designs mainly consider for the 2x2 designs based samples or overall final architecture designs. The final architecture designs, master and slave router designs to be combined for 4x4 NOC design. Master router mainly used to select the input and master internal section and the output for master external section. The input and the another router positions to be slave router designs. First we design the every master internal and external routers and the slave router for overall 4x4 NOC architecture design. Then combined were 16 router to be designed for overall architecture and to star based processing to be applied for central master router for 4 router for 4x4 routing designs. Then to calculate the network interface. The network interface is mainly used to pass the router for master internal and slave positions results to apply for our NOC IC designs. This NOC to be network for passing the data inputs for router to router configurations and the network interface to initialize the routing positions and to passing the central switching conditions and to selection for 4 routing positions. Then the passing for network interface parallel to internal and external position for each and every master and slave router designs. Then the switch and selection control mainly used to transfer the network interface router data and to select the any one of the selection control and based on our the internal positions and to external conditions. Then the selection output data to be passed in each and every routing selection positions. This selection position again to pass the network interface conditions. This network interface condition turn to apply the four routing positions for master and slave position, then to pass the master external router. The master external router to be selected for the four slave positions result and to check the whether the what result to be passing to the outer result. So these results to be selected for based on the selection control and to pass the on-chip peripheral bus. This on-chip peripheral bus to be controlled for overall pipeline connection for forecast for router architecture design. Then to select the overall function and to run the our forecast for NOC architecture design based on the star topology based process. And finally we see the output for the product. First run the Xilinx ISC project for router architecture designs. Our program was developed in VHDL language and using the structural modeling process for router configuration in forecast for NOC designs. Next to select the main router function and to select the simulate model, then to run the simulate behavioral model for overall forecast for NOC architecture design. Then to create the Xilinx ISM project. This ISM project is mainly used to simulate our overall NOC design. Just we apply the binary input data for forecast for NOC input and to get the output for star based NOC architecture designs based on our selection line. This is the simulation process. Then to apply the clocking signal for overall architecture process. Then to run the reset function for our architecture. Then any of the address to be passed in our NOC architecture designs. Writing signal to be activation for. Then the enabling function to be selection based logic. So activate the one functions for writing the router architecture and read the data for every router architecture functions in forecast for architecture. Then to apply the selection based logic. Then any of the binary data input to be applied for overall architecture. Then to activate the reset functions and to apply the clocking section. Then to deactivate the reset function and to generally apply for clocking function in every architecture design. Then to transfer the data for each 2x2 router architecture design and to get the output for another result whichever the selection based lines and to passing the results and to apply the final output results for our clocking based output logic due to the our NOC architecture designs. This is the final simulation process for overall architecture designs. This is continuously apply the input and 16 clock signal to be get the final output results for overall architecture result. This is our processing the overall architecture results for simulation results for NOC architecture designs. Then apply the 16 clock by clock input for our NOC architecture designs. Then to close the simulation process and to select the implementation work. This implementation work to select the main functions and to run get the view RTL schematic. The RTL schematic add and create the schematic. This RTL diagram to represent the what are the logical blocks present in overall architecture. These are the 2x2 router architecture. This is the network interface and to processing the switching activity and final get the master output results. This NOC designs same for the overall architecture function for each and every 2x2 router architecture designs. This is our the RTL diagram for overall architecture process. Then go to the technological process. This technology diagram mainly used to what are the large lookup tables and input output buffers. Then wire connections, flip-flop pairs to be placed in our overall architecture. This architecture mainly represents the area of NOC forecast for NOC architecture designs for final output results. Then go to the design summary process. Then design summary process to synthesis the final synthesis report for our architecture designs for device utilization process and to calculate the timing summary results. The device utilization process mainly represents the lookup table and flip-flop pairs, then the bounded input-output functions, and the Xilinx design timing summary results to be represent the minimum period time and clocking frequency level, then the before and after clock function for overall architecture design. These are the final output results for our Focus 4 NOC architecture designs.